Hi, David Dodge here for Green Energy Futures. This week we're in St. Mary's, Ontario at the St. Mary's cement plant. We're here to find out how a guy by the name of Steve Martin and his company Pond Biofuels take the emissions out of that smokestack and grow algae. So come on in, let's go find out how it works.
Here you can see a pyrometer camera looking straight into the kiln. As you can see it rotating, and the clinker that's being made is coming out, and that's the flame there. That flame there is probably 6 to 8 meters long and is the source of about 40% of the greenhouse gas emissions that comes through that comes out of the stack. 60% of the greenhouse gas emissions are coming from the limestone itself in a process called calcination.
Cement is one of the most widely used materials in modern society. At about 850 degrees Celsius, limestone used to make cement breaks down into two key things: lime and carbon dioxide. St. Mary's produces 720,000 tons of cement, and with that, 540,000 tons of CO2. In a world worried about greenhouse gas emissions, this presents a big challenge. And while the cement industry is working on ways of reducing emissions, they've also started work on other solutions, such as using CO2 to grow algae at Pond Biofuels.
Okay, so over here you can see the pipeline that taps right into the side of the smokestack. Okay, so if you follow me over here, I'll show you where the pipeline leads towards Pond Biofuels. Here you can see the pipeline, heat traced, running along the rooftop, down the side of the building, and over towards the pilot project over at Pond Biofuels down there.
Steve Martin is the founder and chief scientist at Pond Biofuels.
Source of carbon for the algae growth is 100% from the smokestack. There's no other source of carbon for algae growth. So we're recycling a waste product of the cement manufacturing and turning it into a useful product at the same time that we are actually mitigating the carbon emissions.
Steve Martin is an expert in optics. He read an article in the Washington Post suggesting you can make oil from algae, and 12 hours later started Pond Biofuels.
We're standing in front of a bioreactor. It's a large-scale bioreactor to test the commercial aspects of the algae production, and it's a 25,000-liter tank, allowing us to grow algae in a controlled state.
Martin started his work at Pond Biofuels in 2009. This is the third-generation bioreactor. It takes raw smokestack emissions to grow algae, conditions radically different from the sterile labs where much of the algae research has been done in the past.
So there was a realization very early, meaning weeks into starting the company, that we were going to have to work with the raw smokestack gas as it came out of the smokestack in all its glory.
So how does the algae like that dirty smokestack gas?
It turns out that algae will evolve very quickly. We can get 4, 5, 6 generations of algae in a day, and the algae will actually cope with it very well. Another innovation is we selected our algae from amongst the puddles and ponds around the facility here at St. Mary's. We didn't go out and genetically engineer it. Our theory on this was that if the algae is surviving right now in the shadow of the stack, it probably will grow quite well when we deliver more concentrated smokestack to it in the bioreactor.
When Steve Martin started Pond Biofuels, he thought he was getting into the biofuel business. Now he sees his niche as helping the cement industry reduce emissions while turning that waste into a resource.
When you look at it, what does it contain? About 20% of it, between 10 to 20% of it is oil that can be used for producing biodiesel. The remainder has a pretty high BTU value. It can be used as a coal replacement in burning, so a renewable fuel. It has capacity to be used as a soil amendment when you're remediating sites. There's also a considerable amount of protein and starch. It could be used as an animal feed or perhaps even for other uses along that line.
One challenge is that the process requires energy to produce the red light that helps the algae grow. The key is ensuring net emissions are actually reduced. Steve Martin says his focus at Pond Biofuels is growing algae in large enough quantities to reduce emissions at industrial facilities.
Commercial scale, we'd be talking tens to hundreds of thousands of tons per year of algae. And again, keeping in mind that 2-to-1 ratio, every ton of algae you produce is 2 tons of carbon dioxide that has not gone up the smokestack.
Industry is looking to improve their carbon footprint, but how much can growing algae help?
If you could deliver a 5 to 10% reduction in what the facility's putting out, I think you'd have a lot of happy people both in the community and in industry.
This is all still early stages. But someday you may see farms of bioreactors helping reduce emissions at plants and producing algae for a variety of purposes. You can learn more about the Pond Biofuels project and see our blog, photos, and resources at greenenergyfutures.ca. For Green Energy Futures, I'm David Dodge.